NASA has announced that it has detected the first extraterrestrial signals coming from the direction of Proxima B, the closest known exoplanet to Earth, just over 4 light-years away in the habitable zone of its star Proxima Centauri. This discovery created a wave of excitement and curiosity around the world. Could this be the moment when humanity realizes that it is not alone in the universe? The path to this remarkable discovery began with careful observation by NASA's powerful telescopes, which monitored distant stars and planets for signs of life. Proxima B has always been a prime candidate in the search for extraterrestrial intelligence due to its Earth-like characteristics and proximity to our own solar system. The detected signal is unique and unlike anything astronomers have ever seen before, marking a possible turning point in human history. The implications of such a discovery are profound. First, it confirms a long-standing scientific hypothesis that life can exist on other planets under Earth-like conditions. Second, and perhaps more intriguingly, it raises the question of the nature of the civilizations living there. Are they mere microorganisms or advanced beings capable of interstellar communication and travel? This signal from Proxima B is not just random noise or a natural cosmic phenomenon. It contains structured repetitions that suggest an intelligent origin. Now it is up to NASA scientists and international teams to decipher this message, to try to understand its content and the intentions behind it. The global scientific community is full of theories and speculations about the possible content of this message. An invitation, a greeting, a warning, or something completely incomprehensible. News of this discovery bypassed the scientific community and sparked discussions on social media, in boardrooms, and around dinner parties around the world. People look at the stars with a new wonder, wondering about creatures that could do the same in a distant world. How similar or different might their world be to ours? What would their society be like in terms of technology and culture? These possibilities seem as big as the universe itself. Furthermore, this finding raises several ethical and existential questions. How should humanity react if the signals really come from intelligent beings trying to communicate? What protocol should we create for interstellar diplomacy? And most importantly, how would such a discovery change our understanding of religion, life, and our identity as humans? As excitement grows, so does caution. Scientists at NASA and other space agencies are working hard to confirm these observations so that the signal is not a false positive or a misinterpretation. We are on the brink of the most important discovery in human history, so the next steps must be taken carefully and responsibly. The world eagerly awaits a more detailed analysis. Proxima B's detection of extraterrestrial signals not only ushers our scientific efforts into a new era, but also unites us in our shared curiosity and hope. We could finally answer one of the oldest and most profound questions. Are we alone in the universe? In April 2019, a radio signal was detected coming from space, specifically from the region of Proxima Centauri, which is 4.37 light-years away from us. Although this may seem a considerable distance, it is the closest star to the Sun, being 3 times the distance of the third brightest star in our sky. The signal comes from a triple star system consisting of the binary pairs Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the 2 companion stars, are relatively close to each other and quite similar to the Sun. Alpha Centauri A shines with yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright with an orange hue. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is slightly smaller, so our Sun fits right between them in size. But where did the signal between these 2 stars come from? The new Breakthrough Listen project, dedicated to the search for extraterrestrial communications in the universe, called the Signal Breakthrough Listen Candidate 1, BLC-1. Thousands of hours with state-of-the-art telescopes around the world were used to fund the approximately $100 million project. The signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope observed the region of Proxima Centauri, the closest star to our Sun. This signal was almost imperceptible in the massive data collected over thousands of hours, but the researchers managed to detect it like a needle in a haystack. For a signal to be meaningful, it must have 2 specific characteristics. First, it must be limited to a small frequency range, because such radio signals are not generated by the natural mechanisms of space. Second, the frequency must vary according to the exoplanet's relative motion relative to Earth. The researchers had to analyze almost 4 million individual signals captured by the telescope in Australia. After a thorough process of filtering and removing unnecessary signals, they found 5,000 different signals, one of which stood out. A signal that could not be explained after it was cross-checked with modern radio transmitters on Earth. This unique signal with a narrowband technical signature appeared only when the telescope was pointed at Proxima Centauri and observed for 30 hours. After analysis, it was determined that it is the exoplanet Proxima B, discovered by astronomers in 2016 using the radial velocity method, which detects fluctuations in the position of stars due to the gravitational pull of orbiting planets. An asterisk describes a small circle. Scientists use very sensitive spectrographs to observe the star's light. The spectrum of light shifts slightly towards the blue as you move away from it. When these changes occur regularly over days, months, or years, it is accepted that the fluctuation of light is caused by the gravitational pull of an orbiting planet. On closer inspection, Proxima B turns out to be very similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times that of Earth, indicating that it is a rocky world of similar density. However, there are important differences between them. The first is the position of these two planets in their solar system. Proxima B is much closer to its parent star, just 5 cents, while Mercury is 39 cents from the Sun.
That proximity would make Proxima be an extremely hot planet, but because Proxima Centauri is a faint red dwarf, the planet receives only 60% of the energy that Earth receives from the Sun, putting it in the habitable zone where life could exist. There are countless unknown planets in our universe. To date, we have discovered an impressive 49,135 exoplanets and recently added 65 new planets to our list, bringing the total to 5,000 exoplanets. This latest group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year, marking a milestone in the study of planets. The James Webb Space Telescope, JWST, is the most advanced telescope ever, 100 times more powerful than its predecessor. With its help, we can reveal the secrets of the vast space of the universe. We have previously found a wide variety of planets, from small rocky worlds to gas giants larger than Jupiter, as well as very hot and habitable planets. Some planets stand out among these discoveries. Kepler 1649c is one of those planets whose properties are very similar to those of Earth. In fact, it's the most habitable planet we've found so far that could harbor life. So far, we have identified 55 Earth-like planets, but we have yet to study them all in detail. With the rapid development of our technology, especially the James Webb Space Telescope, who knows what else we can achieve in the future? Wouldn't it be great to find a planet that can support life? One of the main goals of the James Webb Space Telescope in its first year is to discover and study cosmic worlds outside our own solar system, focusing on their formation and the possibility that they may contain water and biological life. Webb's study of star and planet formation allows us to connect studies of mature exoplanets to the conditions of their birth, just as we connect our own solar system to their origins. Webb's infrared capabilities are ideal for showing the formation of stars and planets for 3 special reasons. Infrared light penetrates well through dust, detects thermal signatures of young stars and planets, and reveals the presence of important chemical components such as water and organic compounds. Mid-infrared light can pass through clouds 20 times more densely than visible light, which is especially important for observing newborn stars hidden in birth clouds. These infrared properties are crucial because they allow us to observe and record the early stages of star formation, when gas and dust are still contracting to give birth to young stars. However, there is much more hidden in the clouds of birthday stars. Both young stars and giant planets start out as huge, bloated structures that gradually shrink over time. As newborn stars heat up as they age, giant planets cool down, but both emit more light in the infrared spectrum than visible wavelengths. This means that the Webb telescope is perfect for finding new stars and planets and helping to understand the physics behind their formation. With its MIRI instrument, Webb is also looking for hot molecular gas near many young stars, which could indicate the formation of potentially habitable rocky planets. Not surprisingly, much of the early scientific work of the James Webb Space Telescope focused on how planetary systems create molecules that may be crucial to the origin of life.